Hello, this is Yasmin Shhade, and the project I selected is the Metropol Parasol in Spain by Jürgen Meyer. The first algorithm logic I use is a Metapol method to approximate the form of the towers. The Metapol isocurves did not loft as one surface, which resulted in problems when contouring, and I used those curves to extrude them and create a stacking-like effect, but it was far from the result I attempted to reach. The second algorithm logic, I'm going to go into it on the grasshopper file, but just to explain the logic of how to create the top canopy, I use the top circles of those towers by deconstructing the VREP and taking the edge. The top circle has a specific point through evaluate curve, and then those 2 points are connected through a tangent arc. And then the top canopy is created to later be used for kangaroo simulation and also to have a pathway on top of it. So these are some images of the project that shows the waffle structure and how it looks like after contouring. And this is the pathway on top of it. Moving on to the grasshopper file. So I'll start with the tower logic. So I produce the towers through the pipe variable battery. The pipe variable is preferable to use in my opinion because you can control the tower through the main curve, the main axis. So we're taking tower 4 for example. You can control it through different heights and at a sectional radius to specifically choose how to have your final outcome. So this is the tower, and then I used the edges, the naked edges, to select the top circle that is later going to be used to connect it with the other circles and also have the tangent arcs in between. So having selected circle 4, we'll apply arc 4, 3. So I specified points on the circle. So since we're doing arc 4, 3, the points are on circle 4 and circle 3. So the arc also depends on a start point, end point with a tangent. So the tangent would be at that specific one of the specific points on the circles. So this is arc 4, 3. Sometimes I did need to adjust the seam of the circles to get better results, but not for all towers. Moving forward, so this is the result of the towers. I'll just turn the preview on and enable it. So as you can see, these are the 6 main towers, and we'll continue on producing the top canopy. So I'll also turn this preview on and enable. So to produce that top canopy, I had to shatter the circle at the intersection with the arc. So this is in order to create the joint curve that produced this canopy. So by using curve intersection, I was able to select specific points and then shatter the circle and produce the joint curve that you'll see in a bit. As you can see here. Unfortunately, it's not showing because of the canopy, so I will have to turn that off. So yeah, the circle was shattered according to the intersection, as I mentioned. So we have, for example, those 2 intersections between arc 4 and 3 and arc 4 and 3 from 3 to 4 from the other side. So with those intersections, the circle is shattered, and then we have this part of the circle is joined to the arcs, and then this is how the whole curve around the tower is produced. So when the curve is joined, as you can see highlighted in green, I used it to produce the surface through patch, and I also increased the flexibility of that, and finally offsetted the curve, patched it again, and I also offsetted the surface using the pufferfish plugin, which is helpful to offset the surface on grasshopper rather than doing that on rhino, since it does not have one normal in one direction, because it has inward and outward projections. So then I used the top face, deconstructed the BREP, and just used the top face to apply the physical simulation and produce the also the pathway on top. So I'm not going to go into detail for the pathway, but it's based on the joint curve. So I selected specific points on that joint curve to have restriction for the pathway, not to go beyond the top surface. So those are the points, and then I use the curve on surface battery and divided that curve, moved the point, and had the surface resulted towards the end by lofting it and having the railing around it. So I'll show you that over here. And sorry for the file, but it's really slow. So this is the loft with the railing. It's more clear on the PDF, but just to give you an idea of how it is, and can be changed along the top canopy. So for the contour part, I'm gonna turn the towers off. So the contour is pretty much straightforward. It's at angle 45 on the XY plane. Two sets of contours that were applied on the towers with the canopy. And then I use boundary surface to create surfaces out of these curves, and I offsetted them on the rhino file. So as you can see, the waffle structure is created in that manner. And to finally apply the kangaroo simulation, I will turn the towers on with the top canopy and just apply the kangaroo simulation on the top face. So these are the towers with the top canopy. So I turned the surface into a mesh, joined and welded the mesh, used the naked vertices as anchors. So these are the naked vertices. Just give it a moment. Okay, these are the anchors. I applied vertex loads with a strength that can change. Also, edge length is set at length factor 0, all plugged into the kangaroo solver, and this is the resulted mesh. So I'll initiate it again. That's pretty much it. If you have any questions, please go ahead.